Our focus for this video will be looking at basic trig integrals. This is using indefinite integrals, and it's just looking at the very basic level of all the trigonometric functions. So we have 6 different formulas that we can look at. The integral, keep in mind, is an antiderivative. So what I'm looking at on the inside, what we call the integrand, is a derivative, and we're working backwards to the original function that gives me that derivative. So if I ask myself, what would give me a derivative of cosine? Well, the answer would be sine of x, and then you have to put plus c behind all your antiderivatives for the indefinite integrals. So then if I look at sine, if that's my derivative, the function that gives me that derivative would have to be negative cosine. Since the derivative of cosine goes to negative sine, the negative is reversed here, which can be a little tricky, so you got to watch your negative versus positive signs on all of these. The antiderivative secant squared is tangent. Cosecant squared is going to go back to negative cotangent x plus c. Cosecant x cotangent x, when I integrate that, goes back to negative cosecant x plus c. And then the integral of secant x tangent x just goes back to secant x plus c. Once you have these memorized, then it's just a matter of applying it to the problem that's given to you. So for instance, let's say I'm trying to find the antiderivative of 3 times sine x. Well, the 3 is just a coefficient, so that's just going to remain as a coefficient on my antiderivative. And then based on the formulas from the previous page, the integral of sine goes back to negative cosine x, and then plus c goes behind every answer. Now I could check this. If I take the derivative of this, so I want to take the derivative of negative 3 cosine x plus c. The derivative of cosine goes to negative sine, so this would actually become positive 3 sine x. And then the derivative of c, which c is a constant, goes to 0. Notice the derivative, 3 sine x, is the same thing that I began with the integrand. And so you can always check your work by differentiating your answer to make sure it matches what is on the inside of the integral. So with the next one, I want to find the antiderivative of 4 minus secant x tangent x. Well, 4 doesn't involve any trig, so that's just a regular antiderivative. 4 goes backwards to 4x. And then secant x times tangent x, its integral goes to secant. So this is minus secant x, and then plus c behind the answer. Now, when we start looking at the more complicated functions, then we're going to look at things that it doesn't necessarily fit the formula from the very beginning, and so I'm going to have to figure out a way to manipulate it to fit one of the formulas I already have memorized. So for instance, if I look at the integral of sine of x divided by cosine squared x, I don't have a formula for that. That wasn't written on that previous page. So then what I have to do is figure out, okay, how can I rewrite this to get it into a form that I do know the antiderivative for? So with this one, because I see the cosine squared on the bottom, I'm going to go ahead and split that fraction apart and make that sine of x over cosine x times 1 over cosine x. I'm allowed to do that because I have 2 cosines on the bottom, and multiplication you're allowed to just kind of push them apart. And once I do that, you should see sine over cosine is tangent, and 1 over cosine is secant. And I do know the antiderivative for tangent times secant. That's the same thing as secant times tangent. This is just going to go back to secant x plus c. So then our last one, we have sine squared plus cosine squared. Well, I don't know the antiderivative of sine squared or the antiderivative of cosine squared. I know regular cosine and regular sine, but not when it's being raised to the power of 2. So then I have to figure out a way to rewrite this. Well, I know sine squared is the same thing as sine of x times sine of x, but that doesn't help me any because I don't have a rule for multiplication, and so I can't break apart the sine x times sine x. So then I have to think, okay, what else do I know? What else have I learned from like pre-calculus or another math class that would allow me to simplify this integrand into something easier? You might recall that sine squared plus cosine squared is actually equal to something. This is what we call the Pythagorean identity. Sine squared x plus cosine squared x is equal to 1. And so now if I'm integrating 1, that just goes back to the function of x and then plus c. So ironically, that one actually does not end up being a trig function, because once I rewrite it into something that I know it's equivalent to, it actually eliminates the trig. So occasionally when we simplify things, it actually makes it a lot easier, which is the point of simplifying, of course. So when you get something that's really complicated looking, see if you can simplify it. If it can't, then you'll have to use a different method, which we'll learn later on.